Hey guys, welcome back to my YouTube channel. So welcome to the data structure series. So in the previous session we have discussed about the binary search. So in this session we'll discuss about the linear search over there. So how linear search is going to work over there. So imagine we have some non-sorted array element, like imagine we have element here as a 3 and 9 here, 12, 2, 10 and 15 over here. So this is your array element. Imagine this is your array element and your indexing always is going to start from 0, 1, 2, 3, 4 and 5 over here, right? So now imagine your target element. So let's take one specific target element. I wanted to search it for 10 here. So I wanted to search the target element, that is 10 over here. So how we are going to do into the linear search here is, first we are going to take the first element from the array and we are going to match with the target element. If it is getting matched, the search is found. If it is not, just increment the pointer to the next indexing position and same match with the target element. Keep on repeating the same process until and unless you find the specific target element from the array over here. So that is how the things is going to work. So if I talk about the algorithm for it, so if it is an array, of index, we are going to iterate with the I value. If it is equals to target element, then we have found the specific element over here, right? So if this specific condition is satisfied, we found the target element. Else what we need to do, we need to increment the value here. So we need to increment the array value. So I plus plus over here. So we are going to do I plus plus over here. That means we are going to increment with the one step over here. So now my target element is 10 here, right? So first I am going to find 3 is equals to 10. No, just increment the 1. I am just going to tell increment the array of I over here. Now we are going to find the array of first it will be like array of 0. Once I increment the array of I, then it will be array of 1 over here. What is the array of 1? The value is 9 here. So again I am just going to match 9 is equals to 10. No, cancel it, and we need to increment the array of I over here. So then when I increment the array of I, it is going to the array of 2 over here. So it is going to find the array of 2. Again array of 2 is 12. 12 is equals to 10. No, again increment the process, then it is going to 3 here. So what is the array of 3? Array of 3 is 2 here. 2 is equals to target element, that is 10. No, again increment the value of array in the indexing position, then array of 4, then array of 4 is basically a 10. So 10 is equals to the target element. Here we found the element over here. We have found the specific element over here. So it is how the specific linear search is going to work. So when you talk about the time complexity of it, so what can be the time complexity here? So imagine it will be a big O of n over here. Why? Because it is a worst case over here, right? Because it is a worst case, because if there are an element, suppose I am searching for an element that is 30. So 30 is not at all inside this specific array, even though we need to traverse the length of the entire, how many times your array is going to run at this scan. If the element is not present into the array, at that time the search is going to perform for the n time, right? N time is basically what can be the n? N will be the length of the array, over here. For the length of the array, we need to perform the specific operation for it with the specific formula. At that time, this specific algorithm is not much sufficient, not much precise for the searching purpose. If your element is finding at the first, what can be the best case in this? Imagine if I am just finding for an element 3. In this case, I am just finding with the starting iteration itself, right? In this case, we are just finding the element in the starting iteration itself. And that case, this will be the best case. That might be the big O of n, because in a single occurrence, we are finding this specific element over here. So worst case will be big O of n, because it is not much precise to use it for a large specific searching algorithms over there. So I hope you have got this entire idea about the linear search. When we talk about the binary search, which we have discussed, in this case, this was the better approach, right? This will be the better approach. It will be the better approach for searching. This is the better approach for the searching compared for the linear search, because here we are just divide and conquer. We are just dividing the entire array, then we are performing the search over there. In this case, this is the best case for if we compare with the linear search. I hope you have got this session. Take care. Bye bye.